Hi viewers, welcome to LMS Solution. Today we are going to see about MATLAB simulation of adaptive PO for CMPPT control for solar PV system. What's the difference between that normal PO and adaptive PO for CMPPT? In PO MPPT algorithm, normally we have to measure PV voltage, current, and then we need to calculate power. That means change in power and change in voltage. Based upon change in power and change in voltage, we need to adjust the PV panel voltage or adjust the duty cycle. This the concept was implemented in the PO MPPT. In adaptive PO for MPPT, you have to follow the same thing. That means you need to measure the PV voltage, current, and then we need to calculate the power. And also we need to change in power and change in voltage. Here the fuzzy going to be see the two inputs. One is error and change of error and rate of change of error. So error here is considered as change in power divided by change in voltage, that is the slope of the PV curve of the solar PV system or typical solar PV model. And then the change of error is going to be calculated by delaying that error by some memory block, and then you have to calculate the change in error. So now that fuzzy going to be receiving two inputs. One is error, another one is change of error. Based upon the error and change of error, fuzzy logic control going to be generate the duty cycle. That is a concept began in adaptive PO for CMPPT algorithm for solar PV system. Now we are going to see that simulation, MATLAB simulation is was developed for that adaptive for CMPPT for the solar PV system. Here you can see that we are using solar PV panel here. The solar PV panel rating is 200 watts, and then voltage at maximum power point is 26.3, and current at maximum power point is 1.61. And here you can see that PV and IV characteristics of that consider solar PV panel. Here you can see that at 1000 watts per meter square, the maximum power that means peak power is around 200 watts, and for 500 watts per meter square, the peak power is 101.6, and then for 100 watts per meter square, that means peak power is around 19.49 watts. This is a typical that PVIV characteristics consider the panel. And then here we have that boost converter. That means in between, this is a boost converter placed in between load and solar panel. And here we are measuring that parameter of PV voltage, PV current. This is the input for adaptive PO for CMPPT. Inside you can see that we are calculating the power and then change of, that means current instant power and previous instant power. And then we are calculating change in power here, and here we are calculating change in voltage. After that we are dividing that one here. This is nothing but del P del V, nothing but slope of the PV characteristics of the PV panel. So this is going to be considered as error, and here we are calculating rate of change of error. Thus this will be input for the fuzzy logic system. The output of this fuzzy logic system is duty cycle. So next time when is open that fuzzy designer window. Here I'm going to open that fuzzy inference system for the adaptive PO fuzzy. This is the structure of the fuzzy inference system. Here you can see that this is the membership function we are considered for that error, and then this is for a rate of change of error or change of error. Then we consider duty cycle output, that means output membership function for that adaptive PO fuzzy MPPT. And here you can see that the rules for that. Here we are created around 49 rules, and also you can see the fuzzy rules in the rule view. Here you can see that based upon that change in, that means error value and change in error value, the duty cycle going to be adjust. That means based upon the error and change of error, the duty cycle going to be vary in order to extract the maximum power from that PV panel. So this is a concept of that adaptive PO for CMPPT. Next, here we are measuring that PV parameter and PV voltage, current and PV power, and here we are measuring load parameter, that means load voltage, load current and load power, and also here we are measuring that efficiency of the system. And solar PV is receiving two inputs, one is irradiation and temperature. Here irradiation is, I'm going to vary the irradiation from 500, 650, some 50 and 1000 watts per meter square for every 0.2 seconds. And then I'm going to fix the temperature is 25 degrees Celsius, and then we have to checking the results of the system, whether that CMPPT extracted power or not. And also I'm going to open this PV characteristics 1000, 750, 50 and 500. Check this with this value. This one PV voltage, PV current and then PV power. This is the load voltage, load current and the load power. Next you have to check with that cells, theoretical cells. For 500 watts the peak power is around 1.6. Here you can see that the peak power is around 100 watts. For 650 watts is around and the peak power is 131.8. Here we can check that results. I'm going to check the power. Here you can see that is around 131.7. For 750 watts the peak power is 151.7. Here you can see that the peak power is 151.6. Already I told that for 1000 watts per meter square the peak power is 200.1. Here you can see that the peak power is 200. The adaptive PO MPPT algorithm effectively extract the maximum power from that PV panel. And also we have to check the efficiency. Here we can see that we are getting efficiency at the system. Overall systems around 97.98%. Only around 2% loss in the system because of this boost converter. So this is the working of adaptive PO for MPPT for solar PV system. Thanks for watching our videos. Kindly subscribe our channel and also click the bell icon for notification about upcoming videos. Thank you. Thank you so much.